Test 3, practice, fall 23. Continue. We're on question 4 of the V2 of the practice exam. Waiting for things to clear out here. You're going to have a single replacement reaction in this question. It's going to make hydrogen. I'll write down the parts that you know are coming. You are going to be making hydrogen gas. You will be told you are making hydrogen gas. You will be told the name of the other product. Tin 4 iodide. What are my ions, please? What's the symbol for tin? SN. Oh, man. You're going to have to remember the names are on there. What's the charge? Yeah, 4 plus. What's the iodide? I. Charge. Halogens are always -1. So when you hook those up to make a balanced compound, what do you have? SNI4. And it doesn't even say states are needed, right? Does it have anything about states? Good. I mean, I put the gas there because I read it. Don't cross it off. I mean, it's not. If you give me a state when I don't want it, you will not have any trouble from me. In fact, if I say states are not required and you give me the wrong state, I'm just going to cross it off. I won't give you a minus anything. Okay? So you don't need anything for SNI4. We do need the reactants. HI, we have to know our hydroic acids. It will be a hydro-blank-ic acid. We got 4 versions of the tests and 4 popular halogens. I'm just telling you. You're going to have HF, HCl, HBr, or HI. That's you. How many hints can he give us? HI. Don't give me a state. I don't need it. Plus just good old SN. It's going to be some kind of element there. Please don't put a charge on it. No charge. It's an element, right? Balancing this one's not too bad, I don't think. 2 numbers or 1 number? 2 numbers. 2 numbers. The iodines looked like a good place, right? Because you know you need 4. Right? So purple last all the time. Purple last. And now you have too many hydrogens on the left, don't you? That's not a good way to say it. You have more hydrogens on the left than the right. You have to compensate. That's a better way to say it. That's balanced. Yeah. And I don't think we have to do more than figure out what's going on. And you got the answer. Tin is gone. It's going from there to there, isn't it? I'm going to erase that blue arrow soon, the light blue arrow. That's what's happening to tin, right? Does tin have more or less electrons when it's done than it did before? How do you get a 4 plus charge? Sorry? How do you get a 4 plus charge? Don't tell me you can add 4 protons to an atom. Never, ever tell me that. It doesn't happen in anything except for nuclear chemistry. We're not doing any of that. So you're allowed to change the number of electrons, right? So Jessica's there. He's not listening to me. All right, Jessica, what do you want to tell me? Yeah. That's what I have to do. Remove 4 electrons. So tin is losing electrons. Losing electron. Don't say lur. No, not always saying lur. You're saying Leo. Leo the cat. Leo, we had a play with Leo last weekend. Yeah, HFC put on a play. I don't know what it was about. But anyway. So tin is becoming oxidized, correct? That's one of the answers. I'm getting rid of the blue arrow. Yeah, oil rig's a good way to go. Or tin losing electrons oxidation. Tin is becoming oxidized. And the other story is H that used to be an ion that's plus became H2. Well, it went from +1 to 0. Remember, oxidation state of an element is 0. H2 has an oxidation state of 0. So how do you go from +1 to 0? You got to gain an electron. Grrr. H is becoming what? Is becoming reduced. Thank you. Oh, that didn't work. Why? I got this big line here. Okay. And I would do the agents to the right. You don't have to. If tin is becoming oxidized, then it must have caused the other thing to become reduced. So you're going to say, and the way I want these written, tin, the thing that became oxidized, had to reduce the other thing. It's the reducing agent. Tin is becoming oxidized and is the reducing agent. How's that? Or therefore? It's not a therefore. That's just semantics. I'd give it to you, Sam. And is the reducing agent. That's 2 points right there. Now, careful how you do the next one. Because the whole species is the agent. So H is actually part of something when you started. So you say, and HI is the oxidizing agent. Sorry. If H became reduced, it means it caused the other atom to get oxidized. But it's part of HI when it's an agent. And HI is the oxidizing agent. So there's 4 points in the green, red, and blue. So I don't know, put a little box around it. We hate yellow, so that's good for boxes. 2 points is the balanced chemical equation up top, I think. 3 points up there. And then 1 point each for the green gets a point, this red gets a point, the blue gets a point, and the other red gets a point. And that's the end. There's a lot more to these questions when you get to 141, I'm promising you. Redox will drive you insane at 141. Okay, and we had a question back there. I'm going to stop the video first.